Welcome back. Going into more statistics today. Measures of central tendency and dispersion. Gonna try to be fast because I know sometimes I'm kind of slow, but we're looking at SID2 now. Use statistics appropriate to the shape of the distribution of data to compare the center and spread of different data sets. So lots of vocab. Measures of central tendency, outlier, mean, median, mode, measure of dispersion, and the range of a data set, which I'm sure you've heard of most of those terms before, but we're going to do them again. So, yeah. Another fun question here that we're going to talk about tomorrow. It says, refer to the data at the right. Which basketball player would you rather have on your team? Justify your answer. So you've got player 1 and player 2. You can go ahead and think about that a little bit. Like I said, we will talk about it in class when we're doing 6.2 assignment. So think about that. We'll come back to it. This says you can use different measures to interpret and compare sets of data. One way to summarize a set of data is to use the measure of central tendency, meaning the center. So mean, median, and mode are all ways you can measure the center of a data set. The measure of central tendency that you would want to use depends on whether the data has an outlier or not. An outlier is a data that is either much greater or much less than the other values, so it's kind of doesn't really follow the pattern of the other data. Below is a review of what the mean, median, and mode are and when to use each of them. So the mean is just the average. It's when you take the sum of all the data values and then you divide by the total number of data values. So you add them all together, divide by however many numbers are. When to use this? You use this to describe the middle of a set of data that does not have an outlier. So if it doesn't have an outlier, then you want to use the mean. The median is just the middle value. If you put them in order, least to greatest, it's going to be whatever value falls right in the middle. And we're going to use the median when there is an outlier. The reason that we're using the median is because the median actually doesn't take into account the value of the numbers. It just takes into account the location of the numbers or the position of the numbers. The mean does take into account the value of each number. So for example, if you have an outlier of 500, then the mean is actually taking into account the value of 500 versus just the median would say that 500 is at the end of the set of data, be the largest data value. So it's not actually taking into account the value of the data. That's why we're using the median as when there is an outlier. Okay, and then lastly the mode. Don't use the mode a whole lot, but it's just what data value occurs the most. Okay, a data set can have no mode, one mode, or multiple modes. We really only use the mode when we're talking about non-numeric data. So if I said, what is your favorite color? Blue, red, green, purple. Then I would use the mode because median and mean wouldn't make sense in that case. So that's when you use the mode, when you're doing non-numeric. This is an example of a numeric example, or a numeric data set. Okay, it says what are the mean, median, mode of the bowling scores? Which measure of central tendency best describes the scores? So again, this is numerical, so probably not the mode, but we still can find the mode here. So first of all, let's find the mean. So the mean, what we're going to do is going to be a fraction. We're going to add up all the numbers, 104 plus 117 plus 104 plus 136 plus 189 plus 109 plus 113 plus 104. Now we're going to divide that by how many total numbers there are, and there was 8 bowlers, so we'll divide by 8. And if we do that, I believe we get 122. I think, if I'm remembering correctly. Okay, so that'd be your mean. So that means on average, the bowlers bowled 122. Okay, your median. Before you can find the median, we want to put them in order from least to greatest. So let's hurry and do that. So my smallest number is 104, and I have that 3 times. So 104, whoops, 104, 104, 104, takes care of those 3, then what, 109, 113, 109, 113, 117, 136, and 189. Okay, so our median is going to fall right in the middle. So start crossing these off. 1, 1, 2, 2. I like to count like this. That way I don't. You're always pairing them together. So then 3, 3, 4, 4. So actually, right in the middle of these, there's 2 that are in the middle. So I actually have to find the number in the middle of those 2 numbers. So what you can do, if there's 2 numbers that fall in the middle, which will always happen if you have an even number of data values, is we take and we add the 2 in the middle. So 109, we basically just find the average. Plus 113 divided by 2. Or if you can figure out what the middle number is fairly easily, then you can do it that way. And in this case, that is 111. So our median is 111 because that number falls right in the middle of the data. And then the mode last is just the one that comes out the most, which is still 104 because that comes up 3 times. The rest of them only come up once. I think that writing is right in the way. Dossier desktop trial. There we go. So your mode is 104. So looking at this, which would be the best to use in this case? Well, you have to ask yourself, is there any outliers? So if you look, the most likely one that would be an outlier is bullet 5 here, 189, because that is quite a bit higher than the rest of them. The rest of them are pretty close to, 110-ish. Bullet 4 has a pretty high score also compared to the rest of them, but 189 is quite high. So if we use your mean, that's saying that the average person got 122 about, but really only 2 people got higher than that. So in this case, probably the median is best, the best central data or central point, because there was about half they got above. There was half they got above 111 and half they got below 111. So most central number is probably 111 here, the median. And that's, again, because this 189 is a little bit of an outlier, so it's pulling that mean up. Okay, it's making it higher, but not necessarily pulling the median up that much. It pulls the mean up a lot more because it takes into account the value. Okay, so now I want you to try this. It says consider the problem 1 that is, consider the scores from problem 1 that do not include the outlier. So basically, do problem 1 again without including the outlier. Or, yeah, so get rid of the 189 and then figure out what the mean, median, and mode are. And then, yeah. So I'm not going to do this one, but I have faith that you guys can do it. Okay, so let's move on to this one. You can use an equation to find a value if you're given an average. It says your grades on 3 exams are 80, 93, and 91. What grade do you need on the 4th exam to average 90 on all of your exams? So we want the average to be 90. So if we're finding the average, that's the mean. So I'm going to have a fraction here. I know there's going to be 4 exams total. I want my average to come out to be 90. I know my first 3 are 80, 93, 91. I don't know what my 4th exam is going to be. That's what we're trying to figure out. So that's going to be my x. Okay, so if I add them all together, divide by 4, I want that to come out to be at least 90, or equal to 90. So then I just solve this equation. So what I want to do is probably add the tops there. So 80 plus 93 plus 91 is 264. So this is 264 on top, plus the x still divided by 4 equals 90. If I want to solve this equation, we need to get rid of the denominator first, so multiply by 4 to both sides. Those cancel. Ka-chow. Then we get 264 plus x equals 360, 90 times 4. And then subtract 264. And then we get x equals 96. Okay, so if you want to average a 90 on the 4 tests, then you have to get a 96 on the final test. Okay, so we can do that when you're given a mean. We want it to be 90. You can figure out what the other scores need to be. Okay. Okay. What grade would you need on your next exam to average an 88 on the 4 exams? And yeah, okay, so go ahead and try this one, and then we'll come back and talk about it. Pause this in 3, 2, 1, pause. Alright, so basically the same problem, you're just changing the 90 to an 88 here. And after you go through and solve that, I got 88. So actually, if you want to have an average of 88, you only need to get 88, versus if you want to have an average of 90, you have to get 96. So it's a little bit harder to get the average up to 90, especially when you've taken 4 tests already. The more tests you take, the harder it's going to be to raise that average, unless you're doing well on those. If we look at part B here, it says if 100 is the highest possible score on the 4th exam, is it possible to raise your grade to 92? So if we change this to 92 now, that'll just change these two numbers. 92, 92 times 4 is 368, minus 264 is 102. So you'd have to get 102 on your next test to raise it to average of 92, which again is not possible if 100 is the highest score. So you actually can't raise your grade to an average of 92, unfortunately. 91 might work, but not quite 92. Sad day. All right. Finding the range. A measure of dispersion describes how dispersed or how spread out the data is. One measure of dispersion is called the range. It's just the difference between the greatest and the least data values, so the highest number subtract the lowest number. This one, finance. The closing prices in dollars of 2 stocks for the first 5 days in February are shown. What are the range and the mean of the data? These results compare the data sets. So it wants the range and the mean. So if we find the mean first, we're going to add them all up and then divide by, what's that, 4, 5, something like that. So the mean, 25 plus 30 plus 30 plus 47 plus 28, we're going to divide that by 5. So if we do that, 25 plus 30 plus 30 plus 47 plus 28 divided by 5. Your mean is 32 here. Let me erase this so we can see. If we add all of these ones up and divide by 5, we get 34 plus 28 plus 31 plus 36 plus 31 divided by 5, and it's the same thing. They're both 32. Now we can find the range, which is the biggest number, subtract the smallest number. So our biggest number here is 47, smallest is 25. 47 subtract 25 gives us 22, so that's your range. This one is going to be 36 and 28. 36 subtract 28 is 8. So they both have the same mean. However, the range in stock A is much greater than the range in stock B. So we can say stock B is more consistent than stock A. They both have the same average, but stock A ranges low to high more than stock B does. So it has a higher range. So it's dispersed, it's more spread out. Okay, for the same days, closing prices in stock D. So now we have stock C and stock D. So go ahead, find the mean and the range, and I will do the same, and we'll come back and talk about it. Pause this in 3, 2, 1, pause. Alright, so I've done stock C and stock D, found the mean and the range. The mean in stock C is 2.2. The mean in stock D was 11.2. Range was 6 for stock C. Range was 22 for stock D. So stock D clearly has the higher mean, higher average. However, it also has a much higher range because your highest number was 24 and your lowest number was 2. So those data values are a lot more spread out, a lot more inconsistent, we can say, than stock C. Stock C was 1, 3, 4, 6, or 7. So you kind of know what you're getting with stock C. Stock D is a little bit more variable. Not really sure what's going to happen with stock D. Okay, last thing we're talking about is a line plot. This is also called a dot plot sometimes. But basically you're just plotting your data values on a number line. So on this one it says the results of a survey on the number of televisions in a student's household are shown in the list below. We want to make a line plot of the data. So when you're making a line plot, it's just a line, and then you want to go from 1 to 5. So we've got 1, 2, 3, 4, 5 here. So how many 1s do we have? There's 1, 2 1s, so I'm going to put 2 things here. You can use whatever. I just use X's because they're easy to draw. There's 1, 2, 3, 1, 2, 3, 4 2s. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 3s. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4 4s. And then 2 5s. That's what a line plot looks like. Okay, it's kind of like a histogram, honestly. It's just with X's instead of bars. So then calculate the mean, median, and range. So actually, if you look at this line plot here, you can see that it's actually symmetric. It's perfectly symmetric. There's 6 in the middle, then the 4 on the 2 sides, and 2 on the outside. So your mean and your median are going to be this peak here. Your mean, median, and mode are all the same when it's perfectly symmetric like this. So your mean and the median are the same, and that's just going to be the middle number, which is 3. Your range is just going to be 5 minus 1, which is 4. Okay, so that's an easy way to do it after you've made the line plot already. That way you don't have to go add up all of these things and then divide by, however many numbers there are. How can you tell from the graph the mean and median are equal? Again, if it's symmetric, you can just look and tell. However, if it's not symmetric, then you have to go through and add them all together and whatnot. So that's not super fun, but if it's symmetric, it's nice. Okay, this one, the results from the same quiz given to 2 different classes are shown in the line plots. Which class has a higher standard for being in the top half of the quiz scores? So when it says top half, okay, that's basically asking you to find the median. Which one has a higher median? Okay, so if you look at this one, well, again, it's perfectly symmetric, so your median's going to be right in the middle here, about 3.5. This one is not symmetric, so you have to kind of find the median here. So if we start like crossing them off, there's 1, 2, 3, 4, 5, 6, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21, so our 11th term should be the one in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this one should be in the middle, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah. So there's 10 on each side of that. So the median on this one is 5. So class B has a higher median. Yeah, so it's a higher standard to be in the top half. If you want to be in the top half in class B, you have to get at least 5. If you want to be in the top half in class A, you have to get 4 or above. Next it says comparing. By comparing line plots, how can you tell which mean is greater? Well, that's pretty easy. There's more data on the right here. Okay, because this is actually skewed left, but there's more data on the right. So your mean is obviously going to be higher in class B because there's more scores that are higher. Okay, the mean in class A is going to be 3.5. If we want to find the mean for class B, well, you'd have to go through and calculate it, but because it's not symmetric. But we can tell that it should be higher anyway, because it's skewed. More data on the right. Okay, and I think that's all I have today. So sorry that again wasn't super quick, but it's under 20 minutes, so it's a plus, I guess. All right, do your quiz and be happy about it, and I will see you all tomorrow, hopefully. Okay, thanks, bye.